Lesson 7, we are looking at constant rate of change. So our two words we're looking at here are rate of change. And a rate of change is a rate that describes how one quantity changes in relation to another. In a linear relationship, and remember linear means, as you can see, a line. You can see it right there. So any relationship that when you graph it, it forms a straight line is a linear relationship. The rate of change between any two quantities is the same. So a linear relationship has what we call a constant rate of change. All right, and an easy thing that people confuse with rate of change is a proportional relationship. And let's just be clear right from the start here. You can have a constant rate of change, but not be in a proportional relationship. And we'll look at what that means a little bit later here. So let's look at our real world link. A computer programmer charges customers per line of code written. So we're going to fill in the blanks with the amount of change between consecutive numbers. So that's what we're looking at. We're looking at rate of changes. How much change is there between each event? So looking at the lines of code, all right, we go from 50 to 100 to 150 to 200. So from 50 to 100 is a change of 50 lines. All right, 100 to 150, again, another change of 50 lines. And then from 150 to 200, another change of 50 lines. So as you can see, each event, the amount of change stays the same. So let's look at the cost then. From 50 lines is $1,000, 100 line is $2,000. So 1,000 to 2,000 is an increase of $1,000. 2,000 to 3,000, increase of $1,000. And 3,000 to 4,000, increase of $1,000. So it says label the diagram below with the terms change in lines and change in dollars and constant rate of change. Okay, so here we go. We've got a ratio set up, $1,000 to 50 lines. Well, the $1,000 is our change in dollars. And our 50 lines represents the change in the number of lines, just like we determined in our chart above. All right, so that reduces down to $20 per one line, and that's your unit rate. So the constant rate of change is $20 per line of programming code. So that means for every line of code, the cost is going to increase $20. A constant change for both comparisons. So one way to find your constant rate of change is to use a table, much like we did in our little introduction there. So let's take a look at example 1. The table shows the amount of money a booster club makes washing cars for a fundraiser. Use the information to find the constant rate of change in dollars per car. All right, so here we got our table. Let's look at what changes we see. So if we go in the number of cars washed, we'll look at the number of cars washed first. So from $5 to $10 is an increase of $5. From 10 to 15, another increase of $5. And from 15 to 20, another increase of $5. So let's look over then at the cost. From 40 to 80, increase of 40. 80 to 120, an increase of 40. From 120 to 160, we have another increase of 40. Okay, so we're going to use the unit rate to determine the constant rate of change. So remember, up above, it said the rate of change in dollars per car. All right, so we're going to look at change in money over change in cars. All right, so we said our change in money, we said was $40 each time. All right, $40. And I just realized I have a 6 written there, so that should be a 40. So we have $40 was the change in money. the change in cars was 5 cars every single time. And if we reduce that to its unit rate, where we have a 1 on the bottom, 5 reduced to 1, we divide by 5. 40 divide by 5, because that's what we did with the 5 below, and we get $8 per one car, or we can write that $8 per car. So what does this mean? This means that for every car that goes to the car wash, their money increases by $8. So another way that you can identify the constant rate of change is by using a graph and looking at the graph of the situation presented to you. So it says you can also use a graph to find a constant rate of change and to analyze points on the graph. So here's an example. It says the graph represents the distance traveled while driving on a highway. Find the constant rate of change. It says to find the rate of change, pick any 2 points on the line. And you can do that. You can pick any 2 points. And they have 4 points labeled right there for us. They have 0, 0, 160, 2, 120, and 3, 180. They recommended that 2 easy points to pick would be 0, 0, and 160. So we want to set up a rate that compares the change in miles versus the change in hours. So this key here is the change for both of those. All right, so let's look at the first situation in miles. So if we pick the points 0, 0, and 160, we want to find the difference in the miles, or how much the miles changed. Well, the miles are represented by our y-axis here, distance right there. So in 0, 0, that would be 0 and 60. So what we want to do is find out how much change occurred there. So we're going to subtract those two. We're going to subtract 60 and 0. So that would be 60 minus 0. Then we're going to find the change in hours, which for 0, 0, again, hours is our x-axis here, all right, our independent variable. Hours are 0 and 1. So we'll simply subtract 1 and 0. And when we do that, we get 60 over 1, or 60 miles in 1 hour. So our unit rate becomes 60 miles per hour, or you might see that written as 60 mph as well. So there's one more thing that they wanted you to do. They wanted you to look at some of the points on this graph and say, what do these points actually represent? So we got the points 0, 0, and 160. So let's start with 0, 0. What does that really mean? And to figure that out, let's look back up at our graph and kind of analyze the whole thing. All right. So overall, the problem said that the graph represents distance traveled while driving on a highway. So let's look at the point 0, 0. Well, the first 0 represents our x-axis, or the amount of time that has gone by. So the point 0, 0 means that if you do not have any time, if no time has expired at all, how far have you traveled? Well, you haven't traveled anywhere, because you're still at 0 on your y-axis, which represents your distance. So down here, the point 0, 0 represents traveling 0 miles in no time. Well, let's look at 160. What does 160 then represent? So let's go back up here again at 160. Well, 1 represents our x-axis, which in this case was time. So 1 represents 1 hour. 60 represents the amount of distance you've covered in that amount of time. So 160, the point 160 means, or represents, that after 1 hour, you have traveled 60 miles on the highway. That's what those points actually represent in a real life situation. And it's important to understand that. So I want you to think about, what do the other points represent? What does 2, 120 mean, and what does 3, 180 mean? You don't have to write anything down, but think about it. What can you come up with? All right, let's look at one last example here. We're going to compare both skills. We're going to find rate of change using a table, and then we're going to find rate of change using a graph as well. So the table and graph below show the hourly change to rent a bicycle at 2 different stores. Which store charges more per bicycle? We're going to explain our answer. All right, so we got Pedals Rentals here first. I'll just label this number 1, and we'll label Super Cycles number 2 over here. All right, so in our first table we have here, we have Pedals Rentals, and we want to know what's the rate for one particular bicycle. All right, so let's take a look here. All right, Pedals Rentals has what appears to be a cost increase. If we look over here, from 12 to 36 goes up $12. From 36 to 48, $12. So that goes up $12 for every, how many hours does it go by? So from 2 to 3 is plus 1. From 3 to 4 is plus 1 as well. So if we look at change in dollars over change in hours, we have a change of $12 for every change of 1 hour. So we could say it's $12 per hour. Well, how does that compare then to supercycles? All right, so we've got this graph over here for supercycles, and they've identified 2 points for us already. That kind of makes things easier for us. So I'll circle the first point. The first point is at 1, 8. All right, you can see that. And our second point is at 2, and that goes up to 16. All right, 216. So again, remember, we're looking at change. So the change in dollars. So in this case, our dollars are 16 and 8. So we'll do 16 minus 8. In our change in hours, we have 2 and 1. So we'll do 2 minus 1. So that gives us 8 over 1, or $8 per hour. So ask yourself the question, which store charges more per bicycle? It would appear that Pedals Rentals charges more because they charge $12 per hour, whereas Supercycles only charges $8 per hour. So go ahead, check out your guided practice, see what you guys can do.